Hello. In this video I'm going to explain how you can load a Box2D physics scene created by the Rube editor into the Phaser HTML5 game engine, which has just had a Box2D plugin released recently, so that makes this kind of thing a fair bit easier. And we're going to look at a pretty simple scene and how you can load that up and find specific objects in the scene and delete them and add new ones and use the debug draw and the mouse dragging and all that kind of basic stuff. So to follow along with this, you'll have to know a little bit about the Phaser engine and a bit about Box2D and also a bit about the Rube editor as well, because I'm not going to explain any of those things in any specific detail. This video is mainly just focusing on how they fit together. But of course, if you're still watching this video by this point, you'll probably have a pretty good idea about how those things work anyway. So let's just get started, shall we? I'll start by looking at the files that I'm going to use. Trying to keep it to a minimum, but you do tend to get a few files once you start doing this sort of thing. To start off, we have two Rube scenes, and one is a level and one is a truck, obviously. And if we just have a quick look at those in the editor, that's the truck there, and this is the level. And I'll just point out while we're here the 0 point in each of these files. So that's there just above this bumpy bit of ground, and in the truck we have 0 at the middle of the truck. Okay, and for each of those Rube files we have a JSON file which is the exported version of that. So that's just the product of this Rube file. We have a couple of files here which I'll get to in a second. In the images folder we have a bunch of images, and they're the images that are referenced by these Rube scenes. And in the sounds folder we have a bunch of sounds. In the JS folder we have just a couple of files here, and these are the two library files. Well, one is the Phaser library file with the Box2D plugin included. Now, at the time of making this video, I'm not exactly sure what these files are going to be called. So you may find in the future, after this stuff is all released properly, because it's not yet released, that these two file names may change slightly, but they won't be too much different. This is Phaser 2.2.2, and I think 2.3 is already out, so obviously if you're using the latest version it's not going to be this one. But just for the purposes of this video I'm going to use these two files here. And okay, so the two files that we are actually going to do editing of are these ones here. So let's have a look at those, and I'll just open that HTML. Alright, so the HTML file is very, very simple. So all we have is those two files that I just showed you before, the library for Phaser with the Box2D plugin, and then Phaser Rube, which is a class and some functions for loading in files from the Rube editor. And then we have this one here, which is the Hello World JS file, which is what we're actually going to be editing. That's it. That's all there is. Alright, so if we look at the Hello World JS file itself, we'll see just the basic skeleton of a Phaser app or game, or whatever you call it. Game, I guess, since it says game. And if we go to our browser and look at the result of that, I think that is this one, yes. So we just get an empty black screen there. Let's do some basic physics stuff first, because I just want to point out a few things about the coordinate systems that are in play here. So I'm just going to, in the preload function, I'm going to load up this image called crate. I'm going to give it the name crate as a resource, and it's going to be the file images crate, which is in my images folder. And to make sure that we actually use that resource, I'm going to create a sprite here using that aforementioned crate resource. So let's see what that gives us. And that gives us a sprite up in the top left because I told it to go to 0, 0. And there's no physics enabled on that just yet. So I just wanted to create I just wanted to show you how you would normally create a physics object without using the Rube loader. So the first thing we need to set up for any physics to happen is, we want to say that we want to start using the Box2D physics system. So that is a must. And then to give that sprite some physics capability, we can then do game physics box2d enable sprite. Now this is about as simple as you can get, but let's see what that gives us. It changes the anchor point on the sprite slightly, so now the center of the image is exactly on the 0, 0 point here. Now what I wanted to do at this point was find out for sure where the 0, 0 point of the world is and bring it to the center of the screen. And we can do that by changing the position of the camera. By the way, there's no gravity at the moment, that's why that physics body is not falling. But let me just grab this, and you can to shift everything to the center of the screen, I'm applying minus 400 and 300 because that's half of my viewport width, like that. And you'll also find that you need to effectively disable the bounds that the camera normally has. It sort of wants to keep itself within a certain region unless you do something like this to say that it's allowed to go to huge distances away from the 0, 0 point. Anyway, so now when I do that, we can see that the 0, 0 point of the physics world is in the middle of the screen, so that'll make things a little bit easier when I'm loading these scenes in, because that's going to be this point here in my Rube scenes. Okay, so to load in a scene, a Rube scene, we do something kind of similar to what we just did with the sprite, in that we first, in the preload, we need to do a load of a text resource. So this time we're loading the file level.json, which is just a text file, and we're assigning it the resource name level. So that's the same as how we load an image resource. And then to make use of that in the create stage, we do this. We assign a variable called level scene, which I'm going to declare at the top here with my other global kind of variables. And we're going to create a new Rube scene object, and we're going to use the resource that we called level, which is level.json. And then we're just going to do load with no parameters yet. We'll have a look soon at what other parameters we can use in here. But I'll just save that and load it and see what that gives us. So now you can see that when this scene has been loaded from the Rube file, it's applying the gravity from the Rube file. So we've set gravity to be minus 20 for some reason. Okay, but that's the gravity that's being applied. And you saw here that the box that we made normally, as in not using Rube, has some physics behavior to it, and it's working in together with the physics stuff that we loaded from the Rube scene. Now, as for sizes, you'll notice that these sizes are a little bit different. and this is quite an important point to note, I wouldn't normally recommend mixing Rube created bodies, so like these ones, with manually created ones like this. And the reason for that is, if we change the pixels to meters ratio, which we can do by immediately after creating the world, we can do this, Game Physics Box2D set PTM ratio, and by default it was 50. So if we change this to 20, let's say, that'll give us a pixels to meter ratio of 20 instead of the 50 that we had before. So just before I reload this, I'll point out this box here is, actually I'm not sure if that box is 1 meter. Let's have a look. Okay, these boxes are 1 meter. That box is a little smaller than 1 meter, so disregard that. But anyway, look at the size of the box that we loaded manually from creating a sprite. It's fairly smallish here, smaller than those ones. Now when I reload this after changing the pixels to meters ratio, you'll see the Rube bodies are all shrunken down, but the one that we loaded manually has not. At least that's how it appears, but in effect it's the same size on the screen, and all these other ones have just become smaller. Now that may not seem like a big deal, but when you're trying to create a game that relies on physics to have certain kind of behaviors, that is actually a big deal, because what we've just done there is we've changed the physical size of this in the world from something that was about the size of a laptop computer, and it's now about the size of like say a refrigerator, a large refrigerator. So that's going to completely change the way the behavior of this works. And the reason it works like that is because if we go back here and see how we got this physics body, we got it just by enabling physics on a sprite. And this sprite, if we check our file, is 32 pixels square. So when we're using a pixels to meters ratio of 20, that's going to be larger than 1 meter, right? It's over 1.5 meters. But the point is, what we're doing with this method is we are defining the size in the physics world based on the sprite, which is not really a good way to do things. What we'd much rather do is define things giving their physics bodies first, and then size the sprites based on that. So for that reason, I would recommend to just make everything in Rube, unless it's really not feasible. And there's only one situation I can think of that's not feasible, and that is where you are loading a small body many times very fast, for example to fire bullets from a gun or something. In that case you might want to load that manually, as we just did for the for this sprite here. So just keep that in mind if you do want to do that kind of loading, that you'll have to think about these sizing issues. Okay, enough about that. Now we'll notice here that even though we do have physics enabled, the dynamic bodies that we loaded from the Rube scene are not moving. So there's one more thing that we need to add in. This time it's going to go in the update function, and that is update Rube sprites. So the sprites that are managed by the ones that were loaded by the Rube loader are managed a little bit differently, but now we should see that they're all moving. They have proper physics behavior now. And to complete the most basic part of the loading, we can also do something like this. And this is something that I recommend getting in place early. Unfortunately, we have a one-line function that can do it for us. So when we add that, now we can see the debug draw. So even if we didn't have any sprites there, we'd still see something happening that we can use to check positions and stuff. Now, as well as the debug draw, it's also very handy to be able to move the scene around a bit to look at other parts of it. And one way we can easily do that is by changing the position of the game camera that we have there. So I'm just going to set up a basic system to change that using the cursor keys, or the arrow keys. This is probably fairly familiar to those of you who have used Phaser already, so I won't go into too much detail, but basically we do this, create cursor keys there, and then in the update function I'm going to add this little bit of if-else statements, so that if the left cursor is down, we're going to move the camera positive -5 and so on like that. So just to show you what that does when I reload. So now I can use the cursor keys to move around. So that's not really anything to do with the Rube loader specifically, but I just thought I'd mention that while we're doing this. And one thing that is a little bit more specific to the Box2D physics stuff is that we also want to have a way to grab things and pick them up and throw them around and just poke them and see how they move, basically. So it's another great debugging tool to have. So the way we can do that is also quite easy. And I'll put this just after my cursors there. And we can do this, which lets us attach some functions to the events mouse drag, start, move, and end, like that. And I'm going to define those functions just below here. So I would recommend basically just copy this in. You don't need to understand it too much, but you can see what's going on here. We're just using the camera as an offset to the mouse pointer, and we're making use of the Box2D plugins mouse drag start, mouse drag move, and mouse drag end functions. So we're just passing that through to the Box2D plugin, really. And when we run that, we should now be able to pick up things and throw them around, and everything looks great. So now we have debug draw, we have a movable scene, and we have mouse dragging. So that's all our basic loading and debugging in place. Now let's see what we can do after loading that makes things a little bit more interesting. So let's look at this load function here. We've left it with no parameters for now, but we can do basic movement of everything that was loaded from this scene resource. For example, we can shift it to be -10 and +5, say. So I'll just show you what that does. So that loads the scene and shifts it -10 and then 5 upwards. I should have pointed out earlier on that the coordinate system we're using here is the same one that Box2D uses. So that is positive values for horizontal are going to the right, and positive values for vertical are going upwards. Alright, I'll just put this back to 0, 0 for now. Now the third parameter that we can use here is a callback function to say what we want to do after this scene has finished loading, because this is all happening asynchronously. So this load function will go off and do something, and then whatever we have after that in this function is just going to continue straight away. So that's why we need to give it a callback to come back and do something after it's properly finished loading. So what I'm going to do is in my physics scene here we have a body called top box, and if I go into images mode we'll see we have an image that is also called top box. And I'm going to find those in the scene and keep a reference to them. And to do that I will... oh, I already have it there. Skipped ahead somehow. So I'm just going to add these two variables at the top here, top box body, top box sprite, and then as the third parameter to the load function I'm going to paste this function as my callback function. So once the scene is loaded we're going to say top box body equals level scene get body top box. So that's the name of that body in the Rube file, and that will give us the body and the sprite for those. Now there's a couple of ways we can check to see that we got them successfully, and for the sprite we can make use of one of the Box2D plugins features, which is similar to this debug draw, but instead of doing a debug draw for the entire world we can do a debug draw for just one sprite. So in the render function I'm going to add a little bit of code here that says if we acquired a top box sprite successfully, then we're going to render it as we're going to do a debug draw for the body of that sprite. So, and that's going to be purple I think, so let's see what that does. Okay, so that's our top box sprite there. You can see it's highlighted in purple as we hoped for. The reason we don't pass a body here is because the Phaser plugin works a little bit differently to how Rube works. Rube works by having one body can have multiple sprites attached to it. For example, this one here. So this one body, as we can see when we run this, it has two sprites attached to it. So of course that's a good thing to be able to do. But unfortunately the way the Phaser engine works is that the sprites own the bodies. So it's a little bit backwards, and for that reason a body always belongs to one sprite, and that's why this function is being called with a sprite instead of a body, because it has to work with the arcade physics engine and the P2 physics engine as well. So that's why that's like that. It's a little bit odd, but we can see that we loaded that sprite okay. Now for the top box body, one thing we can do, well, you could always just do console log and see if we got it, but another thing we could do to check if we loaded it properly, and this will also demonstrate how we can delete things, is we can do something like this. And just for demonstration's sake I'm going to set an interval, so this is going to time out after 3 seconds, and it's going to call a function called delete body, and in my delete body function, which I'll add here, we can see there are a number of ways that we can delete things. We can delete things by calling the destroy function of the sprite. Now, as I just mentioned, the normal way sprites are treated in the non-Rube bodies is that one sprite has one body. So what this does is it removes the sprite and the body, but it's only going to remove that one sprite. So let's I'll just save that, and keep in mind that this body that we're looking at here is one body, but it has two sprites. So when I reload this after 3 seconds, something's going to get removed here. So you can see the body got removed, and the sprite, the one sprite that was with it, got removed, but the second sprite that we had has remained, because that was a secondary one that the Phaser engine didn't really know about. So that's probably not quite what we want. Another way we can remove things is if we for some reason wanted to remove just the body only, we could do game physics box2D remove body, and then we pass the body to it, and it will remove the body only. So just to demonstrate that, so now you can see the body's gone, but both of the sprites remain. So it's a bit unlikely that you would want to do that, but I thought I'd just mention that it's a possibility. So for the purpose of bodies with multiple sprites that were loaded from the by the Rube loader, I set up this function here which is going to clear away all of the sprites for the given body. So this is probably the most commonly desired use. So let's see what that does. So that cleared the body and both sprites there. So that's probably what you want in most cases, I'd say. Okay, just comment that out so it doesn't keep getting deleted. Alright, so we've loaded in a scene. One thing that you probably want to do fairly often is to load a scene and then load other things into that scene. So you would load the game level, and then you might load the player or some enemies, and you might want to spawn enemies repeatedly as the level goes on and so on. So to do that, what we can do is have another scene, and as you may recall, we had another scene here with a truck in it, and we're going to load that. So we can declare another scene here called truck scene, and we can do very much the same thing as we did with level scene, and we can load that by doing, once again, new Rube scene, and we're going to use the resource that we called truck, which I have forgotten to load. Yes. So we also need to prepare the resource, so that's going to be the file truck.json named truck, and we're going to load that, and we're going to load it offset at -6 4. So if I save that and run that, we'll see that this was our 0 point about here, so -6 4 is about here, about there. So the truck gets loaded in there, and as you can see, this is another entire scene with joints and multiple bodies and images and everything. So you can do that again and again if you want to. For example, we could do that. Let's try like this. So that's one way you could load in enemies or something like that while a level is still in progress. Alright, what can we do next? Okay, so let's demonstrate loading while the level is in progress. And I also want to demonstrate how you can get the position of the mouse to use, because in these functions here, mouse drag start, we are using the position of the mouse, but we're sort of passing it through and letting the plugin handle it. So let's try using the mouse position directly ourselves, and we will make it so that when we click the mouse somewhere, a truck will be loaded at that location. So I've got a function here that can do that. So let me just pop that in here. So this function add truck looks at it gets the world location of the mouse cursor, mouse pointer, So that's done. Once again, we need to do some offsetting with the game camera and the current position of the mouse, and then we need to use this pixels to meters function of the physics world, and then we can do, once again, new Rube scene. And I've put this all in one line, but it's basically what we did up the top, but I've just put it all in one line. So we do new Rube scene, and then immediately after that we're going to use that scene to load, and we're going to load at that position. So to do that, when I click the mouse, I'm just going to comment out my mouse dragging for a moment, and I'll take just this one here, which is the on down, so that's when the mouse is clicked down, and instead of doing mouse drag start, I'm going to do add truck. Save and run. Oops, something's not right. Missing slash. Oh, my comment is a little bit weird there, isn't it? Okay, let's try again. Alright, so now when I click the mouse somewhere, we should see a truck loaded at that position. Very good. Works nicely. Now we might want to delete things from time to time. So let me just reinstate my mouse dragging stuff. Mouse dragging, good. Okay, so to delete things, as we saw, we can delete specific bodies and sprites like this. But if you loaded something in, say it's an enemy, let's say the truck was an enemy there and it has it's died and we want to get rid of it. It's a bit of a pain to go around and find all the individual bodies that were part of that scene to delete them. So I've added a function which makes that easy, and it's called clear. Let's see, I'll put that in my timed out. So let's, in this delete body function, I will do truck scene clear. So after 3 seconds, that should clear everybody that was part of the scene that we loaded from truck scene. So let's give that a try. Run. There we go. So it's removed everything from that scene, nice and clean. Alright, we're nearly there. One other thing I wanted to show or demonstrate was the use of some of these other functions that we have for getting things. So we have available get body, get sprite, get joint, and get fixture. So these will get all of the things that you've named in the scene here with the names here. So just as a demonstration of getting some joints. Oh, okay, so there is get body, this is a singular, and then we can also do get bodies. So all of those 4 things I just mentioned, bodies, sprites, fixtures, and joints, we can do the plural and the singular of that. If you do the plural, as I'm about to show, we get an array. Now what I want to do is I want to get a reference to these 2 wheel joints here so that I can turn them when the user presses a key. Now they're both called wheel, so I can do get, well, just copied them from my cheat sheet. Now wheel joints equals level scene get joints wheel. Oh, that's not going to work, is it? Because it's not in the level scene. It's in the truck scene. So I almost screwed that up. It's in the truck scene, and the truck scene is not going to be loaded there. So I need to come down to the truck scene loading function and put it into here. Function. So that should go in there. And I also probably want to have a variable up here that says wheel joints. Okay, so that should load up the 2 joints in this truck scene into the array that I've prepared. And then just to quickly check that we loaded them properly, let's do, in the update function, we'll make both of those wheels turn. So var I equals 0, wheel joints length, and we'll do wheel joints. And now we're using a regular Box2D body, so we can use regular Box2D functions. And set motor speed to, I think 8 should do something. Let's see what happens with that. Nothing. Problem. Length of undefined. Oh, okay. Oh, that's what I wanted to mention too. So it's quite good that happened actually, because otherwise I might have forgotten. Occasionally, or more often than not, you'll find that this update function can be called before your scenes have fully loaded. So what happened there is this wheel joints equals get joints here is not actually, this is not actually executed yet. So what we need to do is give this a check here to make sure that we actually have that wheel joints variable available to use. Otherwise we can't use it. Let's try that again. Okay, now we see that the truck is the wheels on the truck were going round and round, and then it also disappeared, so I kind of want to take out my truck deleting part, which was this. So let me remove that. Now instead of having it just go backwards on it by itself, I want to say, unless the user is intentionally doing something, the speed should be 0. And if he's using the left and right keys, so I'm just going to copy that, remove that part, and bring that down here. So if the player is holding the left button down, we want to make the speed of the wheels 8. Otherwise we want it to be -8. So when we try this, we should find now nothing happens by default. The truck doesn't disappear anymore. But when I hold the left key down, we go left, and right key down, we go right. So there, oh wow, feisty. Huh. Not anymore. So there we go, that's how you can find and use items in the scene. That's pretty much all I wanted to cover in this video. If you have any questions about this, you may probably be best to start with the Phaser forums, and if you're really stuck, you can also try my forums on my website as well. Anyway, so if you do have questions, don't be shy to ask about stuff. And thanks for watching, and see you later.